Hello everyone. This is my PSM1 game on sports team matching, connecting players through technology. My supervisor is Associate Professor Dr. Rohayanti. This is presented by Ali Muhammad Fathi Abdul Qadir Al Burmawi. Um, Proceeding, this is the table of content. We're going to talk about the problem background, the project objectives, the scope, the current solutions, and the development and methodology. And also we're going to talk about and discuss about the system design and architecture. We're going to showcase and demo the interface prototype. We're going to talk about as well the conclusion and the future work. So problem background. Uh, First off, we started with a statistic or a survey. We have conducted a survey on UTM students. Most of these students actually engage in weekly sports events like football and basketball. Half of them, we asked them, what is your biggest challenge in finding teammates? Half of these players, almost more than half, said no players at my skill level. Now, this has two meanings. Either the player cannot find a team that matches his skills, he may be struggling to play, either he is at a low level or a casual level player, which he is cannot compete or he cannot keep up with the high level players, or the vice versa. High level players, they cannot enjoy while having low level players. Also, games are too far away. They find it difficult to reach for games that are far away. And then we have poor communication, chaotic communication, maybe at WhatsApp groups. It's extremely might be extremely chaotic. So this ends up with user priorities. What are they? Skill-based matching. We need a skill-based matching. We need a geolocation coordination. We need in-app coordination, in-app management. Okay. Okay. And then introduction. What is the challenge? These difficulties in finding suitable teammates leads to abandoning the sports. Common pain, we said skill level mismatching, geographic barriers, poor communication tools. Introducing game on sports, team match. Okay. Building sports communities, one match at a time. The solutions, skill-based matching, geolocation matching, and team management. What are the project objectives? We're going to talk about the requirement specification, stakeholder interviews, and UTM student surveys, as we have demonstrated earlier. User profile, sports that includes the sports preferences, includes skill level for different games, so that when they are joining a team or joining a game, it is based on a skill level. We also have game creation and game customization based on skills and based on location, based on might be age as well. And also we have geolocation integration, which solves the problem of having faraway games or uh, just not places that you cannot reach. We're going to be using a Google Maps API, allowing for a location-based searching. We also have a game changer, AI integration, which is DeepSeek API for personalized training tips. We also have the project scope. Now, our scope includes a user profile with skill level. We also have team creation and management. We have geolocation and search filtering. So he's going to be able to search through the location. He's going to be able to search through the sports. He's going to be able to search through the skill level, as well as the AI performance steps. Now, when we're talking about AI performance steps, we're not talking about an AI that have access to history. No, we're talking about a chatbot or a chatting AI that gives out, that is trained to give out or prompt to give out performance tips based on an input provided, a text input or a prompt input provided by the user input, provided by the user. Now, exclusions, what are the things that we are not going to exclude? We're going to exclude direct venue booking. We're going to exclude a payment processing as well. Now, rich literature review, existing solutions. What are the existing solutions that are trying to solve this problem? We have Meetup, Playo. Okay, these are the two most famous solutions. Skill matching. Meetup is not sport specific, or it's not sport oriented. On the other half, like Playo, it is sport oriented, but it is only based on racket games. Multi-sport support. Meetup does not have multi-sport support as it's not sport oriented, while Playo as well is only oriented about the racket games, not football, not these stuff. While Gamon, we do have multi-sport support, skill matching, we have it. Meetup, AI recommendations, does not have AI recommendations. Playo does not include AI recommendations, while Gamon will include AI recommendations. Geolocation, Meetup has a basic geolocation. Playo also have a basic geolocation. Gamon will as well have a basic geolocation. So the gap identified is no platform that combines both skill and geolocation matching with AI coaching. The technology we're going to use here is we have the backend, the front end, APIs, and security. For the front end, since we have a web-based application, one of the famous and one of the most reliable technology stack for backend, for front end is Next.js, since it has a server-side rendering which is faster. We also are going to use TypeScript instead of JavaScript. This will be decreasing the amount of bugs in our code. We also have the backend, Node.js and Express, going to handle the RESTful API endpoints. We're going to be using a non-SQL database for flexibility, since, as I said, not every user is going to have the same sport that he is enjoying, and each sport should include the skill level preference. So we need a non-SQL for a flexible database integration. APIs, we're going to use Google Maps. We're going to use DeepSeek NLP, natural language processor, because we're in the DeepSeek, it is an actor that provides performance tips, while we also have security. We have two important things. We have the geolocation is important. We must, in terms of security, we're going to have authentication, authorization. We're also going to protect the Google Maps geolocation security that we're going to take. And then moving on to the system architecture. Now we have choose the MVC model view controller, a layered architecture. Since we have a complex system, we have a system that needs extreme organization, that needs extreme we need to slow down when we are organizing. We need everything to be blocks so that the view and controller and the model layers can so that the layers can efficiently communicate with each other. We have authentication controller, we have profile controller, game controller, report controller, and notification controller. Models, user, game validation, notification, and report. View, authentication, profile, game view, game edit view, member view, request, admin view, and notification. So the methodology. So why have we chosen the waterfall and not the agile? Now, in this case, we have the requirement, design, implementation, testing, deployment. The criteria that we have chose the waterfall and not the agile. Now the project scope is fixed. We have fixed requirements. We are already done with interviewing the stakeholders, the end users, fixed requirements. We don't have much changing requirements. So we have a well-defined scope that suits the sequential planning, requirement stability, stable user needs, minimal, which means minimal requirement changes expected, fits the waterfall, documentation requirements as well from the UTM department, from the UTM faculty department, requires a comprehensive SRS, SDD, and technical test and STD as well, test the documentation. This emphasizes through a documentation at each phase, stakeholder involvement. We have the supervisor, owner, defined user base, means we have a clear stakeholder hierarchy with scheduled reviews, timeline constraints. Waterfall is best fit for timeline constraints. We have a fixed semester deadlines and milestone submissions, predictable phases align with academic calendar, work experience as well as an individual project with a pre-known skill set. We need a structured approach, reduces the complexity of the management. Now, this is the Gantt chart divided on 14 weeks. This is the Gantt chart for PSM1, market research, user stories, user use cases, test case, use cases, and sequence diagrams. This is the first from week 2 until week until week 6. We're doing the SRS, and then we enter the database schema, API specifications, high fidelity prototypes, test strategy documenting. Now we enter the STD, test cases developments. And then this is the PSM2, project setup, authentication, API development, schema implementation, dashboard implementation, business logic, component library, CRUD operations, performance optimization, DeepSeek API integration. Now moving forward to the prototype, log in, sign up, home page. As you can see, the research, teams, and then moving on to the view joined game from the dashboard, from the menu, and then you can view them, you can leave game, you can chat the host through the WhatsApp. There will be provided a WhatsApp link for each phone number, AI performance coach. We have the profile as well, which you can change, and then the user can report. Conclusion and future work. Future improvements. Enhance recommendation with behavior analysis means we have to use machine learning to enhance the recommendations, team recommendations, mobile application, a dedicated iOS or Android for better access, social features, in-app chat and community, which is out of scope. We have also venue booking, direct integration with local facilities, which will require the local facilities to have their own local systems. And then we have payment secure in-app transactions. If we're going to have a venue booking, everything is going to be done through the app, analytics, user dashboard, and performance insights. This is actually going to be included in the PSM2. Thank you so much. That's it. Building sports communities, one match at a time. Thank you so much.